Okay, so these are actually notes for 3.4. Sorry, started on the wrong screen. All right, these are the notes for 3.4. We're going to learn some different rules for finding derivatives. Last time you learned the power rule. Now we're going to learn the product and the quotient rules. So one of the keys for the product and the quotient rules, and we're also going to talk about higher order derivatives, but we want to make sure that we recognize when to use them. And so if you have two expressions that are being multiplied together, then we're going to use something called the product rule. And if you have two expressions that are being divided, then we're going to use the quotient rule. In theory, we could actually call this first expression right here g of x, and we could call this second expression h of x, and we are multiplying them together. Now, there's no need to think of things that way if you're multiplying by a constant. So, for example, if you have something like this, 5 times 2x minus 1, you do not need to think about this expression as two separate expressions because this is just a constant. However, if you have variables in both portions that are being multiplied, then you are going to need to think about this as the product rule. Now, what some students think, and they hope, and this is wrong, and we're going to talk about why it's wrong, is some people hope that, hey, if I'm doing the derivative of two expressions being multiplied, maybe I could just take the derivative of each expression and multiply that. That ends up not being true. Let me show you and verify for you that that's a false conclusion. I'm going to just take this expression for y and rewrite it as a polynomial by expanding out this product through the distributive property or through FOIL. If I multiply this out, and I'll just go ahead and do some combining of like terms as I go, I would end up with 2x squared plus 9x minus 15. And if I take the derivative of that, and I'm going to use the power rule here, I'd have 4x plus 9. Please notice that it's not the same as just getting the number 2. So finding the derivative of each term independently of each other and then multiplying those derivatives together is a strategy that will fail. Instead, we actually have a rule for finding the product rule. Now, there is a proof of this. See if you can find it or derive it yourself. If you can figure out the proof or find it and write it up yourself in a way that makes sense to you, your teacher will give you bonus points in the class. Okay, so we'll let you kind of pursue that on your own. But let's take a look at the rule and see if we can understand what it's saying. It is saying if you take the derivative, this is notation for derivative, this is based on Leibniz's notation. He didn't say dy over dx because instead of calling the function y, we are just saying the derivative of these two expressions that are being multiplied together. Okay, one expression we could call f, one expression we could call g. The way you can find that derivative is you take the first expression and you multiply it by the derivative of the second. And you're going to add to that what you would get if you take the second expression and multiply it by the derivative of the first expression. In other words, each expression is going to be multiplied by the other expression's derivative. And then you need to add that together. So in this particular situation, what I'm going to do to find the derivative of this is I'm going to take the first expression and multiply it by the derivative of the second expression. I'll use the power rule right there. I'm going to add to that the derivative of the first expression, which is just 2 by the power rule, times the second expression. Oops, let's try to do that correctly. I have now done the calculus. However, I'm not quite done simplifying this. What I want to do to simplify this is I want to make sure that this is factored form. So we are going to factor out all of our answers and make sure that they are as factored as they can be. We also want to say that we have no negative exponents in our answers. And that's how you're going to know that you are done simplifying. So I'm done with the calculus, and now I've got some algebra to do. And so I'm going to go ahead and distribute here, and then I'll check to see if I can combine any like terms, which I can. And then last, I'll factor. And usually the factoring is often a greatest common factor. In this case, it is a greatest common factor. Let's see, we've got 6 x squared plus x minus 2. And it looks like that factor is even a little bit further for that trinomial. This would be 6 times x plus 2 times x minus 1. Now, only the first step was calculus. This was the only calculus. The rest of this was all algebra. And so a common sentence or statement that we'll make often in calculus classes is, it's not the calculus that's hard. It's the algebra. It's the algebra that makes this hard. Okay, now, for this next problem, I'm going to show you two different strategies. One strategy is to use the product rule. I will tell you it is not the strategy I would use. The second strategy would be to just distribute this first and then just use the power rule. But that's okay, we'll show you both ways. Now, it might be helpful in this strategy, either way, to just rewrite this as 5 times x to the power of 1/2. Okay, I'm going to start by using the product rule. So I'll take the first expression times the derivative of the second plus the second expression times the derivative of the first. Now I have to do power rule here, so this would become 5/2 times x to the power of negative 1/2. At this point, I have some work I need to do because first of all, I have to make sure that this expression is factored. Second of all, I need to make sure that I have no negative powers. And actually, I got some issues here with this one because it's neither factored nor does it have negative powers. And there's a couple different strategies here that you could use. You could multiply this out and then try to factor and move negative powers around. But I'm going to actually factor first just to show you an alternative way. Now, as a reminder, I am going to redo this problem without using the product rule, and I think you'll see how it is much, much easier to not use the product rule. However, I'm going to go ahead and I'm going to factor. And what I'm looking for are terms. I've got some monomials here. I have x to some power that's multiplying everything. Now what I need to do is I need to take x out to the smallest power that we have here from each of these terms. Now, by the way, think of this as the first term, the first half of the problem, and this is the second half. I'm going to take x out to the power of negative 1/2. Now, I also have a 5 here. I also have this 5. Both of these terms are being multiplied by 5. I'm going to remove that. And something that's surprising to students is that if there is a fraction, I am going to remove that denominator as well. You might be like, how the heck do I remove that denominator from the first term? Well, it might be easiest to do that if we think about distributing. When you take out a GCF, it's the opposite of distributing. I want to be able to distribute back to this right here. So what I need to do here is I need to make sure that when I multiply this back, I could get back to that 5x to the 1/2, and then I have the 4x. Okay, I'll leave that 4x there for the moment. Well, in order to get back to the 5x to the 1/2, I need to cancel this dividing by 2. And I need to have x here to the power of 1, because when I multiply these back, I would add the exponent. Negative 1/2 plus 1 would give me back to the 1/2. If I multiply these together, I could get back to that 5x to the 1/2, and then I have the 4x. Now, when I continue to distribute, this back portion is really easy because I really took out all of this. So I just have 2x squared plus 1. So now what I've got is inside here, this would be 8x squared plus the 2x squared would be 10x squared plus 1. And then I have this negative power. Now the negative power only belongs with the x portion here out front. So the 5/2 can just still be a 5/2. I'm going to take this, and because it's a factor of the entire expression, I can move it to the denominator as x to the power of 1/2. Feel free to write that as the square root of x if you like that better. I don't care. Doesn't matter to me, as long as I don't have a negative power, and then I still have this 10x squared plus 1. I'm not going to distribute the 5 back into this because I want this in factored form. And I did tell you that I was going to show you how you could do this same problem and completely avoid the product rule. So let's just do this problem again. I'm going to distribute first. And rewrite y as an expression of, let's see, 5 times 2 would be 10. X to the 1/2 times x squared would be x to the 2.5, which would be 5/2. And then I'm going to distribute it to the 1, so that'd be plus 5x to the 1/2. You might notice I'm using x to the 1/2 instead of square root of x. That's because I'm now going to use power rule here. 5/2 times 10. Let's see, that would be 25x to the power of, if I subtract 1, to the power of 3/2. And this would be plus 5 times 1/2, 5/2 x to the negative 1/2. There's my calculus. Done with the calculus. Now I'm going to do algebra. I'm going to factor out the common factor. They each have an x term. I'll take that out to the lowest power. We each have them multiplied by 5, and I have to take out the 2. All right, if there's a denominator there, you need to factor that out. All right, now, to figure out what would go back, let's just check with the distributive property and make sure you can make this distribute back. So 5 times, I need to cancel this divided by 2. I need to have a times 2. And then 5 times 5 would give you 25. This is going to end up being a 10 right here. And then x squared would combine with the negative 1/2 to get you back to x to 3/2. So this would be 10x squared. That would multiply back to 25x to the 3/2 if I distribute. And then for the back term, I just have to multiply by 1. And finally, I've got my answer. I've got 5 on the numerator times the 10x squared plus 1. On the denominator, I have the 2, and I have to move down that negative power of x. Same answer. But I found that to be much easier. The number of steps aren't really that fewer, but boy, it's just way less intense. So if you want to, use the distributive property.